Okay, D part I. So this is easy, guys. It's only one mark. He says FQ of x is this. So FQ of 1, all I need to do is substitute 1 for x. So it's the sum from 1 to n, I to the q, I to the power of q, and then it's essentially 1 to the power of I, but we don't need to put in that 1 because we know 1 to any power is 1. So I just leave it like that. Okay, E. By considering f of x is this 1 plus x, considering it as a geometric series, show that f of x is this. So it's a sum of a geometric series, and we know the sum of a geometric series, our formula is u1 or to the n minus 1 over or minus 1. Now we have our u1 is 1, our or is x, because we're multiplying by x each time, that's the common ratio, and our how many terms are there? Okay, so this is a bit tricky, guys. There's n plus 1 terms because we're going to x to the n. Now normally like the nth term would be u1 or to the n minus 1 because there's kind of one less n than there are terms because of this first term isn't multiplied by the common ratio. Anyway, if you literally count them, look, 1, 2, 3, all the way to n, plus another one here, there's n plus 1 terms. So essentially, I'm getting s of n plus 1. And u1 is 1, or is x, so it's x to the n plus 1, minus 1, over or x minus 1, which is x to the n plus 1 minus 1 over x minus 1, which is what he wanted. Okay, for part F, he says show that f1 of x is equal to this. Now f1x, if you remember, is defined as this. It's x times the derivative of f of x. So it's x times f dash of x. Now f dash of x, if you see this, guys, let's do that first. F dash of x we are going to do using the quotient rule. So if this is f of x, f dash of x is equal to quotient rule using this. So u, let's do it over here, u is x to the n plus 1 minus 1. V is x minus 1. Du dx is n plus 1 times x to the n multiplied by the power, subtract 1 from this power, and dv dx is equal to 1. Therefore, quotient rule, v times du dx, x minus 1 times du dx minus u times dv dx, which is just this, n plus 1 minus 1 times 1, so that's just gone, all divided by v squared. Now guys, the reason I kind of new to use quotient rule, apart from obviously I have to differentiate it, is look, you can see that this is kind of like a quotient rule. Okay, once I have this, let's maybe simplify this a little bit. I'm going to multiply out. So I'm going to get, let's multiply these two brackets first. I'm going to get x, n, plus x, minus n, minus 1, x to the n, minus this, minus x to the n plus 1, plus 1, minus this, plus this, all divided by x minus 1 squared. Okay, I think I'll simplify this a little bit more, guys. I'm going to do x times n times x to the n is actually n x to the n plus 1. That's because that's x to the 1, that's x to the n, add the powers. Plus x times x to the n is again x to the n plus 1, Minus n times this is minus n x to the n. Minus 1 times this is minus x to the n. And then minus this plus 1 all over x minus 1 squared. Now look, some nice things are going to happen. Well, at least one nice thing. We have that cancels with that. Okay, now we're going to multiply x times f dash of x. We're going to multiply by x because that is what f1 of x is. It's x times this derivative. So I multiply this by x, I get n x to the n plus 2, which is what I want here. Okay, that's nice. Multiply this by x, and I get minus n times x to the n plus 1. Multiply this by x, x to the n plus 1, and multiply this by x is x. Divide by x minus 1 squared, and we're nearly there, guys. This is n x to the n plus 2. Take out minus n plus 1 x to the n plus 1. That's just factorizing here, guys. Look, minus n x to the n plus 1 minus 1 x to the n plus 1 plus x all over this, and that is what they wanted us to show. QED. Again, guys, only 3 marks and quite a challenging question. Okay, that's part F. I'll do part G in the next video.